Terminal velocity of various shape in oil.
Introduction. Terminal velocity is the highest velocity attainable by an object as it falls through air. It occurs once the sum of the drag force, Fd, and buoyancy equals the downward force of gravity, Fg, acting on the object. Since the net force on the object is zero, the object has zero acceleration. In fluid dynamics, an object is moving at its terminal velocity if its speed is constant due to the restraining force exerted by the fluid through which it is moving. Objective. First, to investigate the relationship between terminal velocity, Vt of object with same shape but different masses, m. Second, to determine the difference between terminal velocity, Vt of different surface area of plasticine in oil with same mass, m.
Apparatus and procedure. Various shape of plasticine were made and attached to a long thread. The diameter and mass for each plasticine was measured using variocaliper and weighing.
Engine oil was prepared in a long cylinder tube and also the camera for recording. The starting point of cylinder tube was marked with masking tape by 5 cm distance until the end point of measuring tube of the oil column. A video of free-falling plasticine in the oil column and the FMPEG software was copied into that folder. That video was converted into several images by using comment prompt software. Data analysis.
Density of engine oil equals 0.8565 kg/m3. The distance between camera and the oil column equals 110 plus or minus 0.1 centimeter. Frequency of image captured equals 120 fps. Table shows the calibration of distance between the marks, which is 45 pixels is equivalent to 0.05 m. How to calculate and plot graph velocity versus time. Discussion and conclusions. Based on the experimental data plotted, the result for the terminal velocity point was different for each different mass. The terminal velocity from the graph was plotted. The experimental graph follows the curve of theoretical graph that shown as below. According the graph obtained, the graph was slowly constant when it reached endpoint that could be stated as constant velocity. However, the experimental curve of the graph were not exactly smooth compared to a theoretical. Also, the readings from experimental graph were different compared to a theoretical formula. That's all from us. Thank you for watching and listening.